Now you will go into the details of AXI write front-end module implementation. This is the overall block diagram of the AXI write front-end module. The functionality of this module is to store the address coming into the coming through the AXI write address channel in a FIFO, and again store the data packet in another FIFO, and whenever for a particular tag, when both the address and data tags are available, pop from those two FIFOs and write it as or generate an output saying this is AXI write packet. So a complete write packet need its address and the associated data. In the address part, the address and the ID and length field which are coming in the AXI write address channel are packed to as an AXI write address packet and pushed into a FIFO. And in the data packet, again all the data are pushed into a data FIFO, but here it's slightly different because in a single clock cycle you are getting the address ID and length field in the address channel, but in the data channel, in every clock you are getting only one particular data packet associated with the tag. So in every write packet there can be maximum of 16 data. Thus whenever we get the write data packets, you need to store into arbitrary internal storage elements. So we are using 16 set of storage elements as flops here. And finally, when the W last signal is asserted in the write data channel, which is indicating this is the last data in this particular packet, the data can be pushed into the write data packet FIFO. Now once both address and data are available for a particular ID, then the write packet is complete and it can be output as saying that there is a valid write packet available. So the packets in the write address and write data channel will come in order with respect to the ID. So for example, if the master here is producing 5 different writes, then the master will be producing or sending the 5 address channel, 5 address writes and 5 writes in order in the write address and write data channel respectively. But there is no need to do this concurrently. The master can send the first 2 addresses in the address channel, and it can send the next data in the data channel and next few addresses in the address channel and so on. But per channel the packets are assumed to be in order with respect to the ID. Thus whenever we have an entry in both address and data channel, a complete packet is available and a valid signal can be asserted to the output. At this point we will be popping out from both the address and data FIFOs if there is no input hold coming from the top module to this module. So by default the input hold is always asserted, and whenever the arbiter decide to send this particular packet to the OCP client, then only that hold will be released. That means when the hold is released, this packet will be sent to the OCP client. Thus when we are popping these 2 entries and there is no hold coming in, that particular write packet will be sent to the OCP client, and at that point we are sending a write response OK in the write response channel. So whatever is shown here in this symbol are some combinational logics in order to get this functionality written here.